right, guys, we're on day 6 of Unit 10, and in our warm-up, it is saying that we have vertices of a triangle at L, M, and N, and we have to show that the triangle is a scalene triangle. Well, scalene triangles, hopefully you guys remember, have no equal sides. So if you think about our triangle being L, M, N, none of these three sides should have the same length. So we're going to do length for distance, and we're going to hopefully have 3 unequal distances when we're finished. All right, so we're going to say distance of, let's go with LM first. And we'll grab L's and M's x-coordinates, which is 1 and 7, and then their y-coordinates of -1 and -3. 1 minus 7 here is -6, and -6 squared is 36. Here, -1 plus 3 is 2, and 2 squared is 4. And so this side comes out to have a distance or length of the square root of 40. So on LM, I have the square root of 40. All right, next up, we'll do the distance of MN. And the distance of MN is going to be my x's, which is 7 and 2, and -3 and 2. And we'll simplify this. Here, 7 minus 2 is 5, and 5 squared is 25. Here, -3 minus 2 is -5, and -5 squared is 25. And when we add them together, we get the square root of 50. So on MN, that side has a length of square root of 50. And so far, so good. This triangle is coming out scalene. All right, we have one more side, guys, to find the length of, and that's the distance of, let's go with LN. And we have 1 for our x-coordinate and 2 for our x-coordinate, -1 for our y-coordinate, and 2 for our y-coordinate. All right, 1 minus 2 is -1, and -1 squared is 1. And here we have -1 minus 2, which is -3, and -3 squared is 9. And if we add them together, we get the square root of 10. And now we saw that none of our sides are equal, and so we can call this triangle scalene. So all I'm going to do is say that LM is not congruent to MN, and it's not congruent to LN, because no distances are the same. And then I can say that triangle LMN is scalene because no sides are equal. All right. Okay, so last part says to show that triangle LMN is a right triangle using the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. And we have to remember that c is the largest side. And of the 3 sides we found, that's the square root of 50. Don't forget to square it. Okay? My other 2 sides will go in for a, so I'll put the square root of 10 in for a. Don't forget to square it. And I will put in the square root of 40 for b. And again, don't forget to square it. All right, go ahead, guys. Square root of 10 squared is actually 10. Square root of 40 squared is 40. And the square root of 50 squared is 50. And 10 plus 40 is 50, and 50 equals 50. And so we can go ahead and say that the sides work in the Pythagorean theorem. Okay. So triangle LMN is a right triangle. Okay. All right, guys. We're going to work on finding perimeter and area today. And we're going to go ahead and do area first. Okay. So in question 1, we are going to go ahead and graph it. I can move this up a little bit. And K is at -4, 2. I is at +3, -4. N is at +6, +2. And G is at +1, +4. And we're going to go ahead and connect our 4 points in order. So K to I to N to G and back. So what they want me to do, guys, is find the area, how much space is inside this figure. But it is not a figure that we have a formula for, okay? We have formulas for triangles, trapezoids, rectangles, parallelograms, but I don't know what kind of shape this is. You can maybe assume that maybe it looks like a trapezoid, but I don't know if it has any pairs of parallel sides, where trapezoids need at least one. And so a lot of times when we graph our shapes and are asked to find the area on a graph, they are what we call irregular shapes, meaning that they don't have formulas for their area. So we have to do this indirect method of finding the area of this shape. And so what we do is we break it up into shapes that we can find the area of, not inside the shape, but outside the shape. And that's our best bet because it works usually for all irregular shapes on a graph. Okay, so what we're going to do is we're going to put a big box around this. It's almost like if we were packaging this up to send it to or ship it somewhere. We want to make sure that it fits in the smallest box possible. And when we do that and we put this box around it, which is really just a rectangle, it creates right triangles on the outside of the shape. Okay. And why this works is because we can find the area of a rectangle and we can find the area of right triangles that we pat around the shape. And then we're going to do some subtracting out. All right. So here's how you put the smallest rectangle around it. Pick a letter, let's say K, and we're going to go ahead and go straight down from K and then straight over from, let's say, I. And there's one corner of our box, okay? And you guys can see that that formed a right triangle there too. All right. We're going to go straight over from I and straight down from N. And there you can see that we formed another right triangle. Okay? We're going to go straight up from N and straight over from G. And there's another right triangle there. And then we're going to go straight over from G and straight up from K. And there is the smallest box that we can put around our shape. All right. The cool thing is that we can find the area of that rectangle. So we're going to go ahead and say area of our rectangle. All right. Once we find the area of that rectangle, which is just base times height, and our base, let's go ahead and count, is from this corner to this corner. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So our rectangle is 10 by, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So this rectangle is 10 by 8. And that means that the rectangle has an area of 80, which means our black shape in there has an area of less than 80. And so what we're going to do now is we're going to go ahead and subtract out those 4 triangles that we had. If we take this area of this triangle out of the rectangle, the area of this triangle out of the rectangle, the area of this triangle out of the rectangle, and the area of this triangle out of the rectangle, we'll have the area of that shape that's left. All right, and so that's how we indirectly find the area of that black shape inside. So we have 4 triangles to take the area out of. So out of this rectangle comes the area of triangle 1, the area of triangle 2, the area of triangle 3, and the area of triangle 4. All right, so that's kind of how we set it up. So we're going to call this triangle 1, triangle 2, triangle 3, and triangle 4. Okay. Cool thing is we have area of a triangle formula. All right. So I'm going to bring down this minus sign. And area of a triangle is 1/2 base times height. Area of a triangle is 1/2 base times height. Area of a triangle is 1/2 base times height. And the area of a triangle is 1/2 base times height. Okay. And so we're going to go ahead and bring this down. We're going to keep the 1/2. We're going to look at triangle 1 and trying to find his base and his height, okay, which is actually not that bad. It's just counting. Just remember, base and height have to be perpendicular. So you're using the 2 legs of the right triangle. So looking at this triangle 1, his base and his height will be his legs. All right. So across the bottom, we have 1, 2, 3, 4, 5, 6, 7. Remember, count point to point. So this has a length of 7 here. Okay. And then 1, 2, 3, 4, 5, 6. Point to point, that's 6 units. So this triangle has a base of 7 and a height of 6. All right. 7 times 6 is 42, and half of 42 is 21. Okay, so that area is coming out of the rectangle, which is the area of the 80. All right, so we got to do the same thing for triangle 2 next. Okay, so we're going to go ahead and keep the minus sign, keep the 1/2, but we need to know the base and the height of triangle 2. So we're going to go to triangle 2, and it looks like he has a base of 1, 2, 3. Okay, and a height of 1, 2, 3, 4, 5, 6. It looks like 6. Okay, and so he has a base of 3 and a height of 6. And 3 times 6 is 18, and half of 18 is 9. So we're taking another 9 area out of this rectangle. Okay, we got 2 triangles left to go, and so the next one, keep the minus, keep the 1/2, but we need to know the base and the height of triangle 3. Okay, and in triangle 3 here, it looks like he's got a side here of 2. And across the top here, 1, 2, 3, 4, 5. So he has a base and a height of 5 by 2. Well, 5 times 2 is 10, and half of 10 is 5. So we're taking an area of 5 units out again. And we have our last triangle. So we'll keep the minus sign, keep the 1/2, and we just need to know the base and the height of triangle 4. And in triangle 4, it looks like this side here, this leg is 2. And this side up above, his other leg would be 1, 2, 3, 4, 5. So it is also 5 by 2. And 5 times 2 is 10, and half of 10 is 5. And so here we go, guys. We are on the final step. The big box that we put around our black shape here has an area of 80, meaning that if you counted all the squares inside that rectangle, there would be 80 of them. Nobody wants to count all of those. All right. We're going to take out 21 of those boxes, another 9 of those boxes, another 5, and a final 5, guys. And when we take those boxes away from that 80, the amount of boxes left is inside that black shape called KING. And so 80 minus 21 minus 9 minus 5 minus 5 gives me an area of 40 units, because it's area squared for area of king. Ta-da! So it's a little bit of an indirect method there, guys, to find that, but hopefully that makes sense, okay? And if you set it up the way I set it up, I feel like you guys do a better job at it and you don't forget anything. All right? Hopefully that helps, and I'll see you guys on the back side.